اليوم إن شاء الله أنا الموضوع اللي راح أحكي فيه I'm going to give you a glimpse of what to expect when we talk about electricity grid. We'll give you some insight on what to expect for the grid of tomorrow. And it is a very interesting topic simply because we are merging renewables, big data, artificial intelligence, controls, electric power, all in one place. And this tells us basically of how things are moving now. So the world has changed, at least بالنسبة لنا احنا بالأردن اليوم. Renewable energy قبل 10 سنين كنا بنحكي عنها as a dream. Now it is being or it has been realized at a very large scale. اليوم من utility scale ل rooftop systems ل commercial systems عمالنا نشوف الشفت للرينيوبل انرجي. بطلنا نحكي الناس بس بتستهلك كهرباء، اليوم الناس كمان بتستهلك كهرباء من اليوتيليتي وفي نفس الوقت بتولد كهرباء. And the world is still changing. اليوم عمالنا بنشوف transportation عماله بتحول للإلكتريك vehicles وفي electrification of transportation. And this is expected to grow significantly in the near future. And it will continue to change. يعني اليوم لما بنحكي على smart appliances with your mobile phone, with a simple app, you can control nearly all the appliances that you have at your home or at your workplace, and so on. And this is gaining a lot of momentum. With all these changes, the grid has to change too. The grid that we know is nearly 100 years old now. I mean the technology itself, and you cannot expect a grid that is adopting a 100-year old technology to take in all these advancements that we are considering. So this is mainly the conventional grid that we all know. You have generation on one side, transmission, and then you have different consumers, whether they are residential, commercial, or industrial consumers or end users, and they consume the electricity. This is the conventional grid that we used to have for the past, say, 100 years. Now, the smart grid or the grid of tomorrow, we would expect it to have multiple generation facilities with high percentage of renewables and increasing percentage of renewables on the generation side. There is power, and this power is also fed in by different consumers. So consumers are turned into what we call prosumers. They produce electricity and they consume electricity, and they exchange electricity with the grid, and everybody can exchange electricity with everybody else, given that they are on the grid. But what is really important here, it is not just the exchange aspect of the electricity or power. What is important is basically the exchange of information and the flow of information and the amount of information that can be recorded and can be utilized to optimize the electric power generation and transmission and distribution. So a smart grid is basically a system of systems that consists of three main layers. The power layer that we all know, with modifications on that layer, but also we have the communication layer and the IT layer. The communication layer and the IT layers are layers that can enable the existing power layer to become a smart grid or the grid of tomorrow that will allow or enable the bidirectional flow of energy and uses two-way communication and control capabilities between the grid utility and the end users. So the main features of the grid of tomorrow, we would expect distributed resources. We're not talking about 5 or 6 generation plants, central generation. We're talking about distributed generation and interconnection of this distributed generation. So we could be looking at 1,000, 10,000, 100,000, or 1 million power generators from different resources. Many of them could be from solar or wind. In Germany, for example, today, as we speak, we have 1 million prosumers of electricity connected to the grid. And we know for sure that we have a few thousand prosumers now in Jordan. We would expect storage on different levels, from generation to transmission to distribution to end users even. We will have power grid management where we have real-time monitoring of the grid itself. Automation of transmission and distribution. So many of the jobs that we see today, that you have people taking control of what units to operate and how to manage the power on the grid, this is going to be automated totally. And this is going to lead to the optimization of the system itself. We also we will have a dynamic demand response, depending on the grid conditions, depending on the demand profiles for the end users, and broadband over power lines. And this is something that we expect. From the customer power management, we have smart meters, smart buildings and equipment, smart appliances, electric vehicles, plug-in hybrid electric vehicles, and voltage regulation preset energy use. So what would make a smart grid? We talk about mainly 4 different features. The first one is the use of smart devices and smart metering. And we are seeing more and more of these, even as we speak today in Jordan. Most of us have smart devices at home. Most of us have, or many or increasing numbers of end users connected to the grid have smart meters today. We have also the second aspect is new and advanced grid components integrated communication technologies, or integrated with communication technologies. The substations and the distribution infrastructure and the transmission infrastructure has been traditionally built with passive components such as transformers, switch gears, and so on. And you would normally not know what is going on there on a conventional grid. You will need to go to the substation, check what is happening, and so on. And once you install it, you rely that the electricity is going to flow, voltage is going to be regulated, but you have no clue on the patterns of use, how electricity is used during the day. Are there peaks? Is this related to certain aspects related to weather, different conditions, and so on? This is going to transform where we have substations, transformers that are enabled with communication technologies that will allow the data gathering and transmission of data, where this data can be stored and processed, as we are going to explain in a minute. And in addition to all that, we should have programs for decision support and human interfaces. So you will need to utilize this data through human interfaces that are going to be designed to enable end users to make the best use of electricity and tariffs and promotions and optimization of their consumption on one hand, and on the other hand, you will need programs for decision support. And this is where AI can play an amazing role, basically, in relying or analyzing data and giving or proposing solutions, as we are going to see also in a minute. And this is going to be all put together or glued together with advanced control systems. So the grid that we would see, it is not just a power system, it is integrated. This power system is going to be integrated with a communication layer where all points speak to each other and transfer data at all levels, from generation to end users to distribution and transmission, and so on. And even within the house itself, within the end user facility itself, you will have smart appliances, electric vehicle, solar power integrated, and so on. So this is what our substation is going to look like in the future. You have communication devices and data devices connected to the substation, main substation features, and you have a control room where you have basically including automation protection and data storage and all that. Why do we move, or why do we need to move to the smart grid? I think we made it clear. It will enable bidirectional communication and metering, bidirectional power flow, enhanced elasticity of the grid to absorb maximum distributed generation. And we are seeing now signs in Jordan where the grid is under a lot of stress that is basically not allowing further integration of renewable energy systems or renewable energy resources on the grid itself as it stands now. What is, in my opinion, the most fascinating feature of a smart grid is that we will have more consumer choices and more personalized and even real-time tariff structures. So who says that electricity should cost 10 cents or 10 piastres per kilowatt hour, day and night, summer and winter, regardless of your pattern of use? This is not the reality. And the reality is that electricity is produced at different cost, and this cost, it is my right as an end user to see this cost and to see it reflected and to make the choice on when should I use the electricity, when should I store this electricity, when should I support the grid itself and send electricity back to the grid. This will lead to increased energy savings and more features on automation, monitoring and digital control. So where do we see the potential, basically? Imagine this smart grid that collects all the following data. You have end user behaviors, you have end user choices, you have consumption patterns, and this is not for one user or 10 users, we're talking about millions of users. You have performance of distributed renewable energy systems against weather and other operational conditions. So we would have a lot of data on, say, tens of thousands of generation plants, ranging from few kilowatts to hundreds of megawatts, and we can see how the performance is for all these systems and how it varies. And we can have logged data and a lot of data regarding power quality, regarding system faults, and all that. So all this data, what can we do with it? We can have optimized and real-time grid operation and utilization of energy sources and storage capacities. And this is not going to be just limited to choices made directly by somebody who's sitting in a control room. This is going to be automated, and we're going to have AI applications to achieve this. We will have accurate prediction and response to demand changes. We will have condition-based maintenance and self-healing of fault management, and I'll give an example of that. Let's have a look at this diagram where we have a fault here. A fault happened. Some kid was playing with a kite, or you have a thunderstorm or whatever, and this fault happened. So what happens in the conventional grid? There will be a blackout. Everybody will be waiting till a team goes and inspects the site and see what happened and all that, and it takes a lot of time. What happens here is that this fault is detected by the substation. This is transmitted, and this is again transmitted to different points until we reach, for example, the wind turbine. That is the nearest generation point to the grid where the fault happened. So what this will do, it will open a breaker, and this will isolate this segment of the network, and this is what we call basically self-healing. So there is no need for somebody to go actually there unless you are going to fix this problem, but the grid can actually heal itself even with faults happening in different places. Also, one thing that we need to know is, or a question that is being asked today, when should we clean solar panels? How do we deal with dust? This is going to be a question, an easy question to be answered if we have all this amount of data about the performance of solar systems, and we can relate that to weather conditions, dust accumulation, and this is going to be automated. The same thing applies when can we have preventive maintenance for wind turbines. When should we expect them to perform at a high capacity? When should we expect them to perform at a lower capacity? And so on. Smart grid, just to set your expectations in the right level. Smart grid is not a new issue or a new subject. It has been there or ideas have been there for over 20 years. And different aspects of smart grids were integrated at certain stages. One of the largest projects that took place was in Boulder, Colorado. That was around 12, 13 years ago. Unfortunately, it ended up not in a very positive manner. The project cost $2.1 billion. The benefit was $500 million. Now, I'm giving this example just to let you know that it is not as easy as it looks in this presentation. There are lots of lessons that we need to learn, but in the same time, there are lots of opportunities. I can see endless opportunities for young researchers to be working on different solutions that are going to be needed, not just by the grid that we have in Jordan or the grid operator that we have in Jordan, but by everyone who is going to adopt smart grid. And believe me, every grid is going to be transformed into a smart grid. And now is the time, basically, to start working on solutions that answer lots of questions that I more or less highlighted in this short presentation. Of course, there are lots of issues that need to be resolved from a regulatory point of view, starting with data security. How can we ensure that the data that the grid operator is collecting about my pattern of use is not going to be used by or hacked by somebody else? How we can change the grid codes and standards to adapt for smart grid changes? How can we change the tariff structure that is, in my opinion, an outdated tariff structure to a real-time tariff and time of use tariff and so on. We also need lots of regulations related to electric vehicles, infrastructure for electric vehicles, storage, and so on. But these are opportunities. The way we see them today is that these are opportunities for innovation, opportunities for research, and opportunities for innovation and business as well.